Welcome to Module 1, Understanding AI, Past, Present, and Future. In this first module, we're going to be exploring some of the fundamentals of artificial intelligence, what it is, how it developed, and a little bit about where it stands today. Now, at its core, artificial intelligence refers to computers or machines that can perform tasks that typically require human intelligence. These include learning from experience, understanding language, recognizing patterns, solving problems, and making decisions. Now, the evolution of artificial intelligence has brought us to a really transformative moment now in how we work and create. While there's a lot of recent talk about AI, it's actually been around for quite a while. Traditional AI systems, which dominated from the 50s through the early 2000s, operated within carefully defined boundaries by following pre-programmed rules. Take a spam filter, for example. It methodically applied a set of criteria to identify unwanted emails. These tools were powerful but constrained. They can only perform tasks they were explicitly designed to handle and do it in a very methodical way. Now, if we look at some of the historical origins, the concept of artificial intelligence has been around with us longer than you might think, even if it wasn't called AI. According to legend, there were stories even 3,500 years ago of humanoid statues that appeared to move and cry by themselves. And so the idea of non-human intelligence was being considered even back then. Now, in the 20th century, we had lots of science fiction stories about AI, and that emerged from science fiction into scientific exploration mid-century. The 1950s marked a real turning point when mathematicians and scientists began serious work in the field. At the forefront was Alan Turing, a British mathematician and codebreaker who'd already made crucial contributions during World War II by helping crack the German Enigma code. Now, in 1950, Turing published a groundbreaking paper titled Computing Machinery and Intelligence. And in this paper, he posed a really simple question: can machines think? Now, it's easy to get lost in philosophical debates about what thinking means. But instead, Turing proposed a practical test that would become one of the most influential ideas in AI history. This came to be known as the Turing test, and it works like this. You would have a human evaluator, and they would engage in natural language conversations both with a machine and with a human, just like you would see in this diagram. And they wouldn't know which one is which, so they would be doing it blind. They would probably be interacting through some kind of a computer interface. Now, if the evaluator can't reliably distinguish between the human and the machine responses, then the machine is said to have passed the test and demonstrated intelligent behavior. Now, what made this so revolutionary was that Turing shifted the focus away from internal workings of intelligence to the external. He essentially said, instead of asking whether machines can think like humans, let's ask whether they can communicate like humans. Now, I might find this a little more appealing because my background is in communication, and I've often thought about how our communication patterns and our means of communication will reflect on what's going on inside. How do we take our thoughts and share them with others? Through communication. But this is a very practical approach, and what it did is it gave AI researchers a concrete goal to work toward. Now, Turing was remarkably prescient about the challenges involved, and he predicted that by the year 2000, machines would be able to fool human evaluators over 70% of the time in 5-minute conversations. They weren't able to do it by the year 2000, but earlier this year, researchers at the University of San Diego's Language and Cognition Lab found that ChatGPT's ChatGPT 4.5 was able to meet this test 73% of the time. So when they set up this test with the human evaluator, that meant 73% of the time the human couldn't tell if it was the machine that it was talking to or another human. Now, when you work with a new recent chatbot, that's ChatGPT or Perplexity or Claude, see if you think the AI bot is able to meet your expectations for human communication. Now, the Turing test remains really important today because it highlights a fundamental question that we will still grapple with. What does it mean for a machine to be intelligent? Now, the summer of 1956 marked a pivotal moment in the history of artificial intelligence because that's really the first time that the term artificial intelligence was ever used. It happened when there were 4 young researchers that organized what would be known as the Dartmouth Summer Research Project on Artificial Intelligence. It was founded by John McCarthy, who was a mathematician at Dartmouth College, along with Marvin Minsky from Harvard. Minsky went on to start the AI labs at MIT soon after. Nathaniel Rochester from IBM, and also Claude Shannon from Bell Labs. The 4 of them were brought together along with brightest minds in mathematics, computer science, and psychology, and they put together a really ambitious workshop in that summer. The proposal was pretty audacious. They believed that every aspect of learning or any other feature of intelligence could be so described, so precisely described, that you could simulate that thought process with a machine. Now, obviously, that was well before the machines were able to, the technology was able to support this, but they were able to theorize a lot of what has happened ever since in the field of artificial intelligence. So it didn't only give artificial intelligence its name, it really established AI as a legitimate field of scientific inquiry. It set the research agenda that would drive the field for decades to come. What made the Dartmouth conference so remarkable wasn't just its ambitious goals, but how collaborative it was and how optimistic they had of a vision. Now, the organizers believe they can make real progress on machine learning, neural networks, language processing in just a few months. And while they were overly optimistic, some of those problems are still around today. Their approach to breaking down intelligence into component parts that could be studied and replicated really laid the groundwork for everything that early expert systems were able to do, all the way up until today's large language models. So the conference really established some key principles that still guide AI research. Now, when we start thinking about what artificial intelligence entails, what does it include? Let's start by understanding how it's organized conceptually. Almost think of this as nested circles, almost like nested Russian dolls. The outermost layer is intelligent machines. And this is really the broadest definition, encompasses any system that can perform tasks typically requiring human intelligence. And so that's pretty broadly speaking, and a lot of developments that have happened well before current developments in things like large language models. As you move in a little bit, you get to machine learning and then pattern recognition. And this is where machines learn to identify general patterns from data. And this might be recognizing certain symptoms that tend to appear together in a medical diagnosis, or maybe customer behaviors that predict purchasing decisions. What they're doing is they're looking at a lot of data and being able to find that pattern that you would be able to decipher. And maybe humans would be able to do that as well, but the machines are able to do that on a broader scale. Then you get to something called neural networks. And these are computing systems that are inspired by how our brains work. They're designed to process unstructured data. And this includes, images, text, audio. What makes them really powerful is their ability to find patterns in messy real-world data. This really gets beyond what you would typically think about humans being able to do, and gets into a more advanced level of technology. And then really at the center, we have the more recent development, and that's large language models, or LLMs. You'll often hear me refer to this as LLMs. And this gets into generative technology, generative AI, that we're going to spend most of our time really talking about over the course of the summer class. These are specialized neural networks. They're trained specifically to understand and generate human language. And it's primarily language. We'll talk about some other tools as well that are multimodal, but we're going to start and focus primarily on language-based chatbots. Think of tools like ChatGPT or Claude or Copilot, and there are a lot of other models out there as well. Each layer builds upon the previous one. And with large language models, LLMs, they represent some of the most sophisticated AI that we have today. Now, modern generative AI works quite differently from traditional AI and employs some really sophisticated deep learning techniques to understand and create content. Instead of following rigid rules like that spam filter, these systems learn patterns from vast amounts of data and use these patterns to generate new original content. It's not just about recalling, it's about generating. That's why it's generative AI. So let's try a quick exercise just to help understand how generative AI actually works. I want you to look at the sentence. The forest was filled with the sound of singing blank. You put in a noun. It's kind of like one of those Mad Libs. What word do you think would fill in after the word singing? So take a moment, think about this, and don't overthink it, just go with your first instinct. Now, this exercise demonstrates something fundamental about how both humans and AI process language, and especially generative AI process language. When we read or hear a sentence, we're constantly predicting what comes next based on patterns we've learned from all the language we've been exposed to throughout our lives. Generative AI does something remarkably similar, but on a much larger scale. So let's look at these results. Now, most of you probably said birds with high confidence, and that's what sounds most likely, right? The forest was filled with the sound of singing birds, and the probability of that might be really high, like 65% of the time, that would be the word that would fit. But you also could have other words in there, like children. Maybe the forest was filled with the sound of singing children, and maybe that happens just about a quarter of the time. And maybe the sound of singing sopranos is only a tenth of the time, but there's still a chance of those other words falling in. What's interesting is that you can actually assign probabilities to these, and that's exactly how the AI language models work. They've been trained on millions of texts and have learned that in the context of forest, sound, and singing, the word birds appears far more likely than the word children would appear or sopranos might appear. Now, the key insight here is that AI isn't truly understanding language the way humans do. Instead, it's performing really sophisticated pattern matching and probability calculations. It's learned that certain word combinations are more likely than others based on the massive amount of text that it was trained on. Now let's break down some of the terminology. When you hear GPT, and we're all accustomed to talking about ChatGPT is probably the chatbot that you're most familiar with. It's important to understand what that stands for. It's Generative Pre-trained Transformer. Generative means it creates new content. It's not just searching and retrieving existing information like Google might. Instead, it's generating new text by predicting what should come next, word by word. This is why if you have the same prompt in a chatbot and you enter it 2 different times, you'll probably end up with maybe similar answers, but it's not going to be exactly word for word because it's not recalling that data. It's generating new words and new sentences as it's putting together what is probably tied given what the prompt is that you actually had. Now, pre-trained, this indicates that the model has been trained on massive amounts of text from the internet and other sources before you ever interact with it. And it's grown so large that current models, large language models, many of them have been trained on everything that has been published on the internet. And there are also questions about whether or not they've been training on materials they shouldn't have been trained on. And we'll get into that when we talk in a later module about some of the ethical concerns and what that means for copyright. But anybody building a large language model is always looking for more data to be able to continue to train the model, because the greater the data set, the bigger the training set, the easier it is for that model to be able to develop greater capabilities. Now, transformer refers to the specific neural network architecture that it's based upon. And this was introduced in 2017 in a really important paper that some researchers published. Think of it as the engine that makes modern AI possible. It's particularly good at understanding context and relationship between words, even if they're far apart in a sentence. So that transformer is the architecture that's really important in taking all that pre-trained data and allowing the model to be able to generate new text. Now, put all of this together, and the components create a system that can really engage in seemingly natural conversation while actually performing really complex statistical predictions behind the scenes. It's not really talking with you as another person would be, but the effect is almost the same, and that's where it can be really deceptive. Next, I want to show a little bit about kind of that natural language generation and how this works. So after training, we can generate text by predicting one word at a time, as we were talking about. And this shows the magic happening behind all of that. So if you give the AI some input, let's say you ask it to write about a specific topic, that input goes into the neural network, which we represent here as this interconnected web that is the large language model. Think of each connection as representing relationships as the AI has learned between different concepts, words, and ideas. Now, then the AI calculates probabilities for thousands of possible different words. In this example, it might determine that generate has a 0.072 probability, while the next best word, while speak has 0.065 and politics has 0.001. And this is where it becomes really fascinating, because the AI doesn't always pick the word with the highest probability. If it did, it would be very predictable and repetitive. Instead, it uses these probabilities to make a weighted random choice, which is why you can ask the same question twice, get slightly different answers. It's not going to be completely different. It's not going to answer it in a way that's not germane to the topic, to the prompt that you had, but it's still going to be generative and creative in the sense that it'll have different wording for the way that it's describing it. So this process repeats for every single word in the response. The AI generates text one word at a time, each choice influenced by all the words that came before it. This is why longer AI responses sometimes will drift from the original topic. Each word choice affects the probability calculations for the next word. And when we look at some earlier chatbots, you'll see that a longer response would sometimes really drift away from what was originally being asked about. Now, current architectural changes and some other developments that we'll talk about in some more advanced AI tools in like module 3 or so, we'll talk about how they've been able to control for that a little bit better and solve for some of that. But fundamentally, what it's still doing is it's predicting word after word based upon the context, not only of the prompt, but everything that is written so far. What I want you to take away from this is that large language models like ChatGPT, Claude, and others are examples of generative AI. They generate new content rather than just analyzing existing content. This represented a fundamental shift in how we can use artificial intelligence, and part of the reason why there's been such a growth and a disruption in so many areas because of generative AI. Now, before Gen AI, computers were primarily tools for processing, storing, retrieving information. But now we have systems that can create. They can write stories, compose emails, generate code, create poetry, even help with creative problem solving. Now, there's a limit there because remember, this creativity is fundamentally different from human creativity. Humans create based on intention. We have emotion, personal experience, conscious reasoning. AI is creating based on statistical patterns learned from training data. Now, up to this point, that's been true for large language models. And there are some reasons to think maybe they're breaking free of that with some new architectural changes and some developments within computer science. We're not quite clear about that yet. But fundamentally, when we think about generative AI, it's really just based on those statistical patterns learned from training data. Now, both can produce impressive results, but the underlying processes are very different. Human creativity is not the same as creativity coming out of an AI system. As we move forward in the course, we're going to explore how to harness these capabilities effectively while understanding their limitations. The goal isn't to replace human creativity and critical thinking, but to augment it with these powerful new tools. Now, there are a lot of misconceptions about AI. Some people believe AI has human-like consciousness or emotions. There are some really interesting stories of computer scientists that have worried that maybe the AI system has become conscious, and they're worried about what that might mean for the development of a conscious being and generalized intelligence. It really hasn't yet. That doesn't happen. Others might think that AI is infallible, that when it gives them a response after a prompt, it comes across as very reliable and something that they want to believe. But the AI systems still make a lot of mistakes. They can reflect biases present in their training data, and they have what's called hallucinations, which is really a nice way of saying that it makes stuff up. And if you've seen stories about legal briefs submitted by lawyers that they generated from something like ChatGPT, where the cases were made up and there are no cases, those cases actually didn't exist, you'll find that those hallucinations can have a really big impact and can cause a lot of damage. Another common error is the treating AI like a search engine. If you go to a basic chatbot and just ask it for a response, it'll give you an answer, sometimes coming across in a very confident way or confident tone, but that doesn't mean it's the right answer. It's not recalling data. Now, the twist to this might be that when they incorporate web search with some of the tools, and we'll talk about some of these when we get into later modules, that they're able to constrain that a little bit. But even still, I've found that when I use something like Perplexity that's using web search, it will still hallucinate some responses. And we have to be really careful about that and recognize that limitation. So today's AI can perform really impressive tasks, from writing essays, generating images, but it has limitations. We're going to be exploring some of those limitations over the course of these 8 weeks. It can struggle with accurate reasoning, it may hallucinate or invent facts, and it lacks really true understanding of what it produces. So as we progress through the course, we're going to explore some AI tools, examine ethical considerations, discuss how AI might impact your future careers, and we'll learn not just how to use these powerful tools, but how to use them responsibly. So make sure you check on Canvas for the discussion board prompt. Look for the additional readings that you should complete and complete the quiz for this module. And let me know if you have any questions. I'll be posting module 2 shortly after this one's completed.